here at our composition notes from yesterday. We got the entire front side filled out. We reviewed combination functions, add, subtract, multiply, divide. And then we talked about composition, which is actually inputting a function into another. And we did 3 parts for this bottom example. We did f of g of x, g of f of x, and we talked about those do not come out the same. That is not a commutative property. Okay, it is different if f versus g is the outer and inner function. Okay, and then we talked about when you have f of g or g of f of a specific value. Okay, we talked about a couple different ways to solve that. You could try and solve it using the composition function. You could try to solve it doing the, sorry, that was the wrong class periods. We'd already done the back on that one. So let me get the right one pulled up here. We talked about that you could do it all at once. Here we go. Okay, doing it all at once here. Okay, where you say, okay, the 2 is the input inside the g function, which is input inside the f function, and you calculate. Okay, and then I showed you, your alternate was to work inside out, meaning just work the inside first, which is the g of 2, okay, and calculate that, and it came out to -2, and then input that to the outer function and work the outside and find f of -2. And they came out as the same answer. Okay, so you really had a couple of options for the last part. So then on the back, you were asked to try these 3 practice problems where you were doing the same process. Okay, so I'm going to label this as part A, part B, and part C. Okay, so I'm going to do A, B, and C for each of these problems. Okay, remember, there's different ways to write a composition. One way is with the open circle. So this is f of g of x. Okay, and that means I can rewrite it as f is the outer function of g of x. So just like with the double parenthesis. Okay, it can be written this way as well. Okay, so in this case, so that's A, and then B is to reverse that and do g of f of x, and then C is f of g of 6, so a specific value. Okay, so I'm going to start with this first one, f of g of x. Okay, and what this means is we are going to take the f function and we are going to input the g function, which is 4x minus 8, inside of it. Okay, and I'm actually going to color code this. I'll do F in green and the G in purple. Okay, so the G function is going to be my purple writing. And okay, the F function will be my green writing. All right, so we are going to have the F function, which is the 2x minus 3. Okay, but instead of x, I'm going to put parentheses. So 2x minus 3, and I'm inputting the g function, which is 4x minus 8 inside of it. Okay, and so then it's just simplifying. So in this case, I need to distribute the 2. Okay, so that's going to be 8x minus 16 minus 3. Okay, and then I can simplify that a little more by combining like terms. I have 2 constants that can be put together. So that is 8x minus 19. Okay, so for part A, hopefully you got 8x minus 19. If you didn't, you can ask a question if you don't understand what you missed, or get it erased and redone this way. Then for part B, we're going to do the flip side of that. We're going to do g of f of x. Okay, so that means that we're going to have g as the outer function, and we're going to input the f function, which is the 2x minus 3 inside of it. Okay, so to do that, the g function is 4x minus 8. So that's going to be 4, and then I'm going to do parentheses, and then minus 8. And inside the parentheses, I'm inputting the 2x minus 3. So far, so good? Okay, so this time I'm distributing a 4. So that comes out to 8x again. That time it is minus 12, minus 8. So that is 8x minus 20. So that's actually pretty close to the other one, but it's not exactly the same. And we talked about it should not come out to be exactly the same. I'm going to do a little bit of highlighting of just the setup here. So we said here g of x is the input. And here it is the output. So it's on the outside. I'm just going to try and match that color coding we did yesterday, or that, so that you get that good visual of one function is literally being input inside the other function. Okay, and so the difference on A and B was which one was the outside and versus the inside. Okay. All right, now part C wants f of g of 6. Okay, so the process I am going to use here is going to be the inside out. I'm going to work the inside first, which is the g of 6. So I'm going to find g of 6. Okay, so the g function was 4x minus 8. So it's going to be 4 times 6 minus 8. Okay, and I'm going to calculate that. So 4 times 6 is 24, minus 8 is 16. Then I'm going to do the outside, which is the f function. Okay, so I'm going to do f of, and I found out that g of 6 is 16. So the 16 gets input here. So now I'm finding f of 16. Okay, and the f function is the 2x minus 3. So that's 2 times 16 minus 3. Okay, so that's 32 minus 3 is 29. Okay, you may have done it a different way, but you still should have gotten 29 if you did it correctly. Questions about that one? Feel okay about those? What types of functions were those? Both g and f. Those were both linear functions. What do you notice about this second practice problem? What types of functions are these? If these are linear functions, what's g of x? In the second one, that's linear. Okay, but what's f of x? That's quadratic. So this time f of x is quadratic, okay, instead of linear. So it doesn't change our process at all, but for warning, okay, and those of you who tried it realized it probably, it is a little more algebra once you actually get the inputting done and you're doing the simplifying, it takes a little longer because there's more simplifying to do, mainly because you're having to square an expression. Okay, and here x is in multiple spots, so it gets to has to be plugged in multiple spots. Okay, so here's what the f of g of x looks like. Okay, and I'm gonna keep doing my highlighting to color code for you. Okay. So that means the f is the outer function. And I'm going to input the g function, which is negative 3x plus 2. So that means that's going to replace all of these x's in the f function. Okay. So that is going to be parentheses squared instead of x squared minus 5 times parentheses plus 1. Okay, and then both of those places where the x was, I'm putting negative 3x plus 2. Okay, so a lot more simplifying to happen here. First off, what does this do? This power of 2, what does that mean? Yeah, I have to multiply that negative 3x plus 2 by itself. So I have to write it out twice. Okay, and I'm going to have to FOIL that, aren't I? Okay, so, and then here, I'm going to have to distribute this minus 5, aren't I? This minus 5 is being multiplied by the negative 3x plus 2. So that's going to become plus 15x minus 10. Okay, and then you still have the plus 1. Okay, so now in the FOIL department here, remember it's first times first. So negative 3x times negative 3x is positive 9x squared. Okay, last or outer. So the negative 3x times the 2 is negative 6x. The inner, 2 times negative 3 is negative 6x. Okay, and then the last times last. So 2 times 2 is 4. Okay, and then I've got the plus 15x. And I'm going to go ahead and combine these constants here. So that's a minus 9. Okay, is there more simplifying I can still do? Okay, what? What can be combined? What can be simplified? Is there another x squared term? No, so that's going to stay 9x squared. Go ahead. Yeah, I can put these 6x's. What else? Is there another x term? Yeah. So I've got negative 6, that's negative 12, and positive 15. So that's actually plus 3x. Okay, what else can I combine? Yeah, the constants there. Okay, so I had already combined those to get negative 9, but now I've got a plus 4. So now that's just minus 5. Okay, so that one was a little messier because it had a quadratic and a linear instead of just 2 linear functions. Okay, let's see though. If we do B, where G is the outer function and f of x is the inner function, let's see if that makes it any easier or harder. Okay, so this time G is on the outside. And I'm going to input the f function, which the f function is the quadratic. So it's the x squared minus 5x plus 1. So that's going to get input to the g function. So this is, the g function is the negative 3x plus 2. So negative 3x plus 2. And I'm inputting into that x, the x squared minus 5x plus 1. All right, so here, this simplifying is actually a bit easier than part A because I don't have to square a binomial. I don't have to FOIL. The only thing I need to do to get rid of these parentheses is distribute. Okay, this one's a triple, it's a trinomial. So I'm going to distribute that negative 3 to all three terms in there. So that's going to become negative 3x squared. Okay, and then that will become plus 15x, then minus 3, and then you still have that plus 2 there. So anything to reduce or combine? Yeah, my constants. Okay, so this reduces to negative 3x squared plus 15x minus 1. Okay, all right, and last but not least, the C for this one, f of g of 6, I'm again going to work inside out. So I'm first going to find g of 6, okay, which the g function was the negative 3x plus 2. So negative 3, and then I'm inputting a 6 for the x plus 2. Okay, so negative 3 times 6 is negative 18, plus 2 would be negative 16. So that's the inside. So now the outside, the f function, I'm going to input that negative 16. So the f function, this is the one that's the quadratic. So it's x, which we're going to use negative 16 squared minus 5 times x plus 1. Okay, so negative 16 squared is 256. Negative 5 times negative 16 is 80. So we add those and the 1, and we end up with 337. So far, so good? Just looking at the equations for the last practice set, do you think it's going to be more complicated or as complicated as this last one, or a little bit simple, but easier for simplifying? Okay, and why do you say that? Okay, well, there is still a quadratic. I have x squared, but it's a different type of quadratic, right? This quadratic is only a binomial. There's only two terms, where this one was a trinomial. So yes, this one's going to be a little simpler, a little less complicated in the simplifying process because of that. There's one less term, and there's only one x term in that quadratic rather than two x terms. So you're only having to plug in one place. Okay, so let's go ahead and try this one out. So we have f of g of x again. I'm highlighting. So g of x is the input for part A. Okay, so the f function is on the outside, and I'm inputting the g function, which is just x plus 1 this time. Okay, so that is 6 minus, and then the x squared, we're going to replace that x with the x plus 1. I didn't highlight that in green. There we go. All right, so now to simplify, what do I need to do? I still, it's not distributing yet. That negative is going to have to be distributed, but what do I have to do before I multiply? What comes in your order of operations, PEMDAS? Before multiply. Distributing is multiplying. Parentheses. No, there's nothing inside the parentheses to do. So what's after parentheses? Exponents, and we have one of those. Okay, so we're going to have the 6 and the minus. They're not going to go anywhere. Okay, but I need to take care of that exponent, that square, by squaring x plus 1. So x plus 1 times x plus 1 needs to happen first. So I'm going to FOIL that out. So x times x is x squared. X times 1 is just x. 1 times x, again, just x. And then 1 times 1 is 1. Now, here's where you need to make sure you are careful, because that negative was outside the parentheses. All of this is being subtracted. All of that together is subtracted from the 6. So that means now I need to distribute that negative. Okay, so all of the signs are going to change for those. Inside, if you want to go ahead and combine like terms and go ahead and write that as 2x, that's fine. Okay, so this is going to be 6 and then minus x squared. Okay, and then when I combine those, that's a 2x, so that'll be minus 2x. Okay, and then I distribute here. Okay, that'll be minus 1. Okay, so I'm going to rewrite that with the highest degree first. So negative x squared minus 2x, and then my constants can be combined. So a 6 and a negative 1 or a minus 1 is just plus 5. Okay, so now we are going to reverse that and have f be the input function and g be the outer function of the composite. Okay, so when I do this, I've got g of, and then this time the input is going to be the 6 minus x squared. Okay, so the g function is x plus 1. So it's just going to be the parentheses plus 1. And we're inputting the 6 minus x squared. Is there anything to do inside those parentheses to simplify that? No, there's no exponent on the parentheses, so I can just drop the parentheses. So this is just 6 minus x squared plus 1. Are there any combining like terms that can happen? Yeah, the 6 and the 1 again. So that becomes negative x squared plus 7. All right, and then C is f of g of 6 again. So again, I'm going to do inside out. So the inside is the g of 6. I'm going to find that first. I'm going to say, okay, so that's the x plus 1, isn't it? So that's just 6 plus 1. That's 7. So then I'm going to plug that 7 into the outer function, which is the f function. So f of 7. Well, f is 6 minus x squared. So that's the 7 goes there. So 7 squared is 49. So we've got 6 minus 49. So that comes out to negative 43. All right. How are y'all feeling about composition functions? Good? Okay. Your practice for this is in Delta Math. And it has 4 types of problems. Okay, one of them is the timed, okay, where you are simply determining. So when you click start, they give you f and g, and they just say which one of these is f of g of x. Okay, so it's just making sure you understand which one's input, which one's output. So g is inside, so the absolute value needs to be inside the radical, so under the radical. So it's this one, okay? It's not the radical inside the absolute value. You see the difference? So it's just quickly just judging what's inside, what's outside. So this one, f of x goes in for x, so it's square root of x and then minus 1, okay? And so you just keep going through, and some are going to say f of g, some are going to say g of f, so pay attention. You need to get 10 right, And I gave you 2.5 minutes, so it shouldn't be a problem, but you do have to get 10 in a row right, or it'll start your time over. You'll have to start over. Okay, and then there are 3 regular types of questions. Okay, composition with X, that's what we were doing on part A and B. Well, where's our question? That's weird. There it is. Okay, so they give you F, they give you G, and they ask you to find one of these. Okay, so you're just having, it's like you're doing part A or B. You're not having to do both from the notes we were just doing. And then composition of functions is with an actual number input. Okay, so this is like part C of what we were just practicing. Okay, and then the last type is with a graph. This one says visual. Okay, so I do want to go over one of these with you because there was not one in the notes like it, but we did practice with the graphs for inverse functions, so it is similar. Okay, but I'm just going to walk you through this one. You've got the f of x function, you've got the g of x function, okay, the graphs separately. They ask us to evaluate g of f of -2. So that means I need to find the inside first, work inside out, just like we were doing on part C algebraically. But this time we're doing it graphically, but still inside out. So I need to find f of -2. So I look at the f graph. Over here's the f graph. Okay, so I'm looking at this graph on the left for where the input is -2. Okay, so I look on the x-axis at -2 and I find where we are and where my graph is. Okay, and it's right here. So what is that y value? Okay, so our f of -2 is -5. So then I work the outside. So g of -5. So I go to the g graph and I look for where the input is -5. And I go down to the graph and see what is the y value there. It's -8. So that's what you're doing. You're working inside out, just like we did algebraically, but this time it's graphically. Okay, and if you want to remember, you can always see the show example and it will draw those lines I was kind of tracing for you. It has them in color so you can see it stand out a little more. You can see they worked the inside and got an answer and then plugged that in and worked the outside. Okay, just like I walked you through it. Any questions on that assignment or what you need to be doing? Okay, don't forget the inverse worksheet is due today. If you haven't finished that yet, that's what you should be working on first. This Delta Math on composition will be due Tuesday.